This time we're going to look at question 2 of our vertical motion under gravity. Again, draw a picture, get your head around, figure out what's going on. So a ball is projected vertically upwards from a point X. Okay, so we've got a point X and the ball is being projected. Oops, sorry, got the ruler. The ball is being projected upwards, so we'll treat that as our positive direction, as that's the direction initially the ball is travelling, so upwards. So there's our positive direction. And this point X is 7 meters above the ground. So if we draw the ground somewhere down here, so the ground will be underneath. So here's our ground, and that will be 7 meters from our point X. So this distance here is 7 meters. Okay, the ball's going upwards, so we're not going to call that S just yet. We just know that that distance is 7 meters. So the ball is projected vertically upwards from a point X. There it is. And it's being projected 7 meters above the ground, and it's been projected with speed 21 meters per second. So our U is going to be 21 meters per second upwards. That's in our positive direction. And remember, it's going upwards. We're going to have gravity acting. This time it's going to be acting against the direction. So here, the acceleration will be down, like gravity is. But because the positive direction is upwards, that's our direction. So if the acceleration is going downwards, that means it'll be a negative acceleration. Okay, so our acceleration here will be minus 9.8 meters per second to the minus 2. In fact, just let me move that out of the way. Okay, so that's our acceleration. I'll just write this next to it, just so it's how we're used to seeing it. Okay, so our diagram is really important to get that set up properly, and then should be nice and easy to work from there. So let's look at part A. So part A says the greatest height above the ground reached by the ball. So this ball is going to travel upwards to start with. So here it is, it's going to travel vertically upwards. So vertically upwards like this. And because the acceleration here, that acceleration is going down, the speed, although the speed initially is 21 meters per second this way, it's going to start to slow down because it's accelerating downwards. Okay, so eventually this ball is going to get to a point where it reaches its maximum height. Okay, and that will happen when its velocity reaches 0 meters per second. So it's going to start at 21 meters per second, projected upwards, but it's working against gravity, so acceleration is going downwards. So its speed from 21 is going to decrease, eventually it's going to hit 0, and then because it's accelerating down, the speed is going to then start to increase, but it's going to become a negative because it's now going downwards. Remember, the negative is all about direction. So it's going to start at 21, gradually decrease to 0, stop at its highest point, and then it's going to start falling. So speed's going to increase again, but it'll be a negative speed because it's going in the downwards direction here. So the greatest height, so we're looking for S in this question. So we don't know what S is, but we know that U is 21, V is 0, and our acceleration due to gravity is minus 9.8, acting against the motion initially. So to find our displacement from X here, we can use V squared equals U squared plus 2AS. That's the formula that has these 4 variables in. V is 0, U is 21, A is minus 9.8, and we can find S. So square U21, multiply these together, so you get minus 19.6S. Rearrange, divide by 19.6, and you'll get your value for S, which in this case was 22.5. In fact, I don't need to round it. So just straight on the head, 22.5 meters. And we can move on to part B. And part B says, oh, hold on. Part A was, so this is the displacement from X. We want the actual greatest height reached from the ground, don't we? So remember, X is 7 meters above the ground. So therefore, my greatest height reached above the ground, not point X, will just be that displacement from X, which is 22.5, plus the 7 meters that it started above the ground. So 29.5 meters for that question. Okay, then we'll go on to part B. We'll just section that off. So part B says, I can find it. Part B says the time of flight of the ball. Okay, so if we think about the time of flight of the ball starts here. It's going to travel upwards, stop, and then it's going to go back down, and it's going to hit the ground, and that'll be the end of its time of flight. Okay, so we need to find the time it takes to get from its initial point, which is here, down to its very bottom point. So if I get rid of that for now. So we want the ball's going to end up here, isn't it? Okay, and that point here is 7 meters from its initial position at X, but 7 meters in the negative direction, because remember our positive direction is here. So here, S will be treated as -7, because we're 7 meters in the opposite direction to the initial direction of travel. Okay, so S will be -7 meters. A is still -9.8 meters per second squared, because again, the acceleration is going downwards, it's working against our positive direction. U is 21 still, it still starts at 21 meters per second, and we're trying to find this time, we're trying to find T. Let's move this slightly. Okay, so we need our equation linking these variables. So we want S equals UT plus a half AT squared, sub in, so -7. Remember that minus just represents it's down from the point X rather than positive from the point X. Is U, which is 21, T we don't know, plus a half minus 9.8 T squared. Just tidy this up. Okay, we've got a quadratic in T, we've got a T squared term, a T term, and a constant, so we'll get one side 0. Try and get the T squared positive to make life easy for yourself. So 4.9 T squared, so add 4.9 T squared minus 21T, and then you have your -7 equals 0. And then we can stick this into our quad formula in order to solve this, because it's pretty ugly. So T is minus B plus or minus the square root of B squared minus 4AC all over 2A, and sub in. So remember B is our coefficient of the X term, or in this case the T term, so B is -21, so minus B is 21, plus or minus the square root B squared, minus 4A, coefficient of T squared, C, -7. Okay, and if you do this in different stages, that's fine. All over 2A, and A is the coefficient of T squared. And we can stick this into our calculator, and we should get 4.596, or T is -0.310. Now obviously, well hopefully T, time cannot take a negative value here. We're starting at time being 0, so therefore it'll be 7 meters away, sorry, i.e. -7 meters down from our diagram after 4.596 seconds, and that'll be the time of flight. So initially, it's going to go up, reach its maximum height, it's going to fall, and that total time will give us 4.596 if we work it out. So T will be 4.60 seconds to 3SF.